13.4, solving absolute value inequalities, algebra. Essential question, what are two ways to solve an absolute value inequality? And just like solving for absolute equations in the first place, there's graphing and then there's algebraic. I'm going to put more focus on the algebraic way of solving. So in example 1, this is an algebraic way to solve. So here we are, absolute value of x plus 2 is less than 5. So, just like the other problems, just try to get the box, the absolute, all by itself. So we have a plus 2, so let's get rid of that plus 2. Plus 2, add 2, the inverse of add, subtract. What you do to one side, do to the other. Therefore, you're going to get the absolute value of x is less than 3. So, now that the box is by itself, all right, we have to create our disjunction. Here's our disjunction. Now, if you notice, the symbol for x is greater than negative 3, it switched, it flipped. And the reason why is because in your disjunction, we have whatever was in your box is equal to the negative version of the number that's on the right. But since we're dealing with inequalities now, okay, when you have the negative version of your disjunction, your symbol, your inequality will flip. Okay, so that's something you have to remember. So we have x is greater than negative 3, the symbol flip because it's negative 3, and x is less than 3. So if it stays positive, the symbol stays the same. Okay. And now you can write this. Well, because of our disjunction, it said that x is greater than negative 3, and that's written right here in this part. Okay, x is technically still greater than negative 3. And then in the yellow part, actually let's do a light blue, x is less than 3. That'll be this part right here. Okay, and that's how you write the compound inequality. Now, when you graph, you're going to come across a number line, and x is greater than negative 3. Notice how it doesn't say equal, okay? So if it doesn't say equal, greater than or equal, it's hollow, okay? It's a hollow point. Now for the other one, for x is less than 3, okay, it doesn't exist at 3, but it gets right up to 3, but it doesn't touch. And then you have your compound inequality. So it goes through this entire region right here, okay? And that's how you fill in, just like back in the day with inequalities. Mind you that this right here are your solutions, okay? But if you ask you to graph, you're going to have to think like this, and then you're going to have to do something like this, okay? So your question for your answer for your essential question is using the inequality symbols, you can solve an absolute value inequality graphically or algebraically. For solutions, isolating the absolute value expressions and rewriting them as compound inequality. And that's exactly what I did from here to here. Okay, and then of course graphing them if need be. So we still use the disjunction just like the last module for solving for absolutes. The only difference now is we have inequalities. Example 2. The absolute value of 4 minus x plus 15 is greater than 21. I'm going to go ahead and get rid of the plus 15. So again, I'm just trying to get the box all by itself. So I'll use the subtraction property. You should get the absolute value of 4 minus x is greater than 6. The box is all by itself. The absolute value is all by itself. Therefore, we can make our disjunction. So here's our disjunction. Everything inside the box is less than negative 6. So again, you have to remember, if you are doing the whole negative version of your disjunction, your symbol will change. Okay, you need to remember that. If it stays the same, it stays the same. Okay, only when it's negative will it flip. All right, so now that we have our disjunction, we'll solve for x. We'll get rid of those positive 4s or plus 4s, and that's using the subtraction property. You will get negative because minus x, negative x, same, right? And you can't have this, so you can't have negative x equaling something. You have to have, basically a positive x is less than or greater than, right? So let's go ahead and just multiply everything by a negative 1. We could do the same thing with the guy on the right since he has a negative x. Mind you that when you multiply by a negative to both sides, the symbols will flip. So you have to remember about that whole flipping concept, okay? So as you can see, your symbols flipped. They changed. And that's because we multiplied by a negative 1. Just like the symbols change when you make this guy a negative, okay? So when you start adding negatives in there, the symbols might flip, okay? And most likely they will. All right, so we have x is greater than 10 or x is less than negative 2. Let's go ahead and create our compound inequality. And it looks like I went to the graph first, but the compound inequality would be this. X is greater than 10, so we're talking about x. Okay, and we know that x is greater than 10. Okay, x is greater than 10. And then x is less than negative 2. So if x is less than negative 2, I can write it like this. Notice how they're not equal to, they're just less than or greater than. So when you graph it, again, it's hollow here, it's hollow there, but x is above 10, so you shade up, and x is less than negative 2. And that's an or statement, okay? Either one will work. Example 3, let's get the box all by itself. Let's get rid of a minus 10, and the inverse of subtracting is addition. So what you do to one side, do to the other. Then you have the box all by itself because, you finally got rid of that minus 10. And on the right-hand side, negative 2 plus 10 will be positive 8. And now the box is by itself, so we're going to go ahead and write our disjunction. Again, please pay attention to the detail. The symbol changes if you negate, okay? So since you negated for the disjunction on the left side, the symbol will flip. It goes the other way now, okay? Let's go ahead and solve for our two solutions. Subtraction properties. And now you have x is greater than or equal to negative 12, or x is less than or equal to 4. Now they're both greater than or equal or less than or equal. Therefore, when you graph it, it's going to be solid. So first things first, our compound inequality. We're talking about x. X is greater than or equal to negative 12. And x is less than or equal to 4. So I'll go to my negative 12. And instead of being hollow, it's going to be solid. Okay, and that's because it also equals. And then I'll go to 4. It's also solid. Okay, it's shaded in. And then since it's an or statement, you can say x is greater than negative 12, so you can shade up, and x is less than 4. So you'll shade accordingly. Okay, it's basically saying like, oh well, x is somewhere in that region where he's greater than negative 12 or equal to it, or he's less than positive 4 or equal to it. Okay, he's in that region, that range. Okay, actually the domain technically, because it's x, right? So we're talking about domain here. Okay. the last example I want to show you is solving graphically. So just like when we graphed our equations for regular absolute value equations, it's kind of the same even with inequalities. So when you graph these guys, you're still going to look at the same process. Now, what's my h, what's my k for the left-hand side? So my vertex in this situation is at -3. Remember, it's the opposite of whatever h is, comma k, which is 1. Okay. A happens to be 1, so up 1 over 1. So -3, comma 1, and then up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. Draw your A's. Boom, boom. So far, so good. Now, the part on the inequality equation right here, the one that's right here, that is technically g of x. Okay, there's two different equations in here. Okay, technically you can see that 4 as y equals 4. Okay, so y at 4, that's right here. So we're going to draw our line straight across at 4. Okay, so boom, crosses, boom, it crosses. It crosses at 0, at x equals 0, and then it also intersects at -6 for x. Okay, so those will be your solutions, but since we're dealing with inequalities, let's go ahead and see it graphically. So if we do this graphically, we have to get the box all by itself. So I'll subtract the positive 1 from both sides, and you'll end up getting here. You'll have to write your disjunction. So you have x plus 3 is less than -3. Remember, the symbol flips when you negate. Or x plus 3 is greater than 3. Go ahead and solve for our x values. We'll both use the subtraction property. Just your solutions will probably be different. Okay, so you have on the left hand, x is less than -6, or x is greater than 0. And that makes sense because x is less than, it's an or statement, so it's going to be existing somewhere over here, okay, or somewhere over here on your x, okay? And that's basically because your intersections, again, they intersect here at these 2 points when x is -6 or 0. But since it's inequalities, it's anything that's less than -6 or greater than 0. And that's how you would solve it graphically. Algebraically, it shows it a little bit more clean, okay, especially with that whole inequality aspect. Here's your homework, page 617 through 620, numbers 3 through 4, 11 through 16, and 17 through 19. Now, 11 through 16, pretty significant. That's the meat. 17 and 19, there's going to be a problem on your test. That's going to be kind of like one of them. It's, I'll give you a hint, cute and fuzzy animal. All right, definitely cute and fuzzy animal. All right, good luck.